For our next chapter, we are focusing on alkenes. We're going to look at the properties of alkenes as well as how they are prepared. In this video, we'll be starting with a brief introduction to alkenes. Alkenes are compounds that have a carbon-carbon double bond. Here we have our two simplest alkenes. The first one has the systematic name ethene, but it is more commonly known as ethylene. And then the second one is propene, more commonly known as propylene. These compounds are prepared on huge scale by steam cracking of hydrocarbons, and they're produced on the scale of 1.27 times 10 to the 11th kilograms per year, and propylene 5.4 times 10 to the 10th kilograms per year. Now, these are used to make polymers as well as many other small organics. So if ethylene wasn't familiar to you, maybe polyethylene is, polypropylene. So these are the monomers, the starting materials to make polymers that are used for many different applications. There are also natural products that involve alkenes. This really long chain carbon, this is a pheromone of a housefly. And this compound, where we actually have 1, 2, 3 alkenes, this is called beta-myrcene, and this is found in a number of natural products. So this is in allspice, cypress needles, and Scots pine. So alkenes are both naturally occurring as well as synthesized in the lab or in industrial plants. They are important because of how they are prepared, and they're important because of what they can be used to prepare as well. In earlier chapters, we talked about cycloalkanes. Well, there also exist cycloalkenes. This is cyclopropene, cyclobutene, cyclopentene, and cyclohexene. So we use the ene ending to specify that there is a double bond. These small rings in particular are going to be incredibly unstable because these carbons are sp2 hybridized. They want bond angles of 120 degrees, but here they're stuck with 60 degrees. So very, very unstable. But when it comes to six-membered rings, there are a lot of six-membered rings with alkenes in naturally occurring products. This compound is called carvone, and this is found in caraway and spearmint. This one that has two alkenes, this is limonene, and this is found in the peel of grapefruit, lemon, lime, orange. Alpha pinene, it has a six-membered ring and then a bridge. This is also found in cypress needles, juniper berries, pine. And then beta-caryophyllene, this is the Pac-Man compound. This is present in allspice, cloves, lavender, rosemary. So alkenes are found in many natural products, and here we have several examples of alkenes that are components of the essential oils of plants or flowers or spices. Now, we've talked about unsaturation in the context of cycloalkanes. Now, with alkenes, we have another type of unsaturation. So unsaturated means that it's not saturated with hydrogens. It doesn't have the maximum number of hydrogens possible. For example, if we look at ethylene, if it was possible to add two hydrogens, we're not going to worry about how that happens, but if we could add two hydrogens, then we would end up with ethane, and this is fully saturated. We can't add any more hydrogens. The same thing is true with propylene. If we could add two hydrogens, we would have a fully saturated compound. But if these are saturated, that means that these were unsaturated. And we can focus on the degrees of unsaturation, which tells us just how unsaturated it is. And this gives us information on the number of double bonds or rings in a compound. So we need to keep in mind that for an alkane, the molecular formula is CnH2n plus 2. If we have an alkene, now we're looking at the formula CnH2n. So for example, looking at propylene, this is C3H6. But if this were fully saturated and N is 3, it would be C3H. 2 times 3 is 6, plus 2 is 8, so it would be C3H8. We have 2 fewer hydrogens, so we subtract 8 hydrogens if it was saturated, minus 6 hydrogens are present in the molecule. That's a difference of 2 hydrogens. But every type of unsaturation is short 2 hydrogens, so we take the number of hydrogens it's short, divide it by 2, and that gives us 1 degree of unsaturation. So a molecule with the formula C3H6 can have 1 unsaturation. And so that can either be a ring or a double bond. If we have 2 degrees of unsaturation, we could have 2 alkenes, we could have 2 rings, we could have a ring with an alkene, or we could have an alkyne. If we have 3 unsaturations, 4 unsaturations, it could be all different combinations of multiple bonds and rings. Now, you can try to memorize what do you do with the formula when you have an oxygen or a nitrogen or a halogen, but I think it's easier to just focus on, okay, let's say we have something that is a formula of C4H8O. Rather than trying to memorize, okay, with an oxygen you add this, you subtract that, whatever, let's go to the simplest molecules possible. We have the simplest organic molecules. We have methane, and this is CH4. If we had an alcohol, then this would be an OH. So we added in an oxygen, but we still have the same number of hydrogens. So when we have an oxygen, well, it doesn't have any impact. So we would still look at C4H8. For C4, if it was fully saturated, this would be H10, but we only have 8. So we have too few hydrogens, so divided by 2, that gives us 1 degree of unsaturation. Focusing on the degrees of unsaturation, it can be really helpful, especially when you are combining information from different spectra or lab data, trying to figure out what type of compound you could possibly have. So this takes care of our very brief introduction to alkenes.